Hello, everyone, and welcome to this webinar by Streamline Control and Flow Software. Thank you very much for taking the time to join us today as we talk about amplifying your cloud platform's analytics. And we're talking about that specifically in the context of industrial analytics and operational data. My name's Dan Losey. I'm the Director of Analytics and Machine Learning for Streamline Control, and I'm joined today by Jeff Nepper, the Managing Partner with Flow Software, and Lenny Smith, the Manager of Customer Success for Flow Software as well. Welcome, guys.
Perfect. Thanks, Dan. I want to say thanks to our audience. You could have done so many other things in this hour. You decided to spend it with us. So for that, we are grateful. And I'm quite excited to what we've got to show you for you today.
Yeah, absolutely. And thank you, Streamline, for putting this on. We're excited to talk about how to amplify your cloud platform's analytics. But Dan, there's a bit of a problem that I think we need to address straight away. Yeah.
Yeah. So we're here to talk about a problem that many of our customers face, where they've started bringing all of their operational data into the cloud from their SCADA systems and their DCSs, but the picture around that data is incomplete. It's got some rather large holes in it around very important contextual information.
And what we've seen on our side, Dan, is that often it's not a executing of technology problem. It's not that the data is not all arriving, it's a strategy issue. Yeah,
and we'll get into kind of that strategy of where we do the that contextualization. But first, we're going to talk a bit about kind of why this problem matters. And really, in order to do that, we want to look at the goals of any data and analytics initiative. And it's always got to tie back to the goals of the organization. So within industrial operations, the goals are often reducing or improving safety, reducing downtime, reducing environmental footprints, and improving efficiency. Those are kind of some general ones. There's often many more. But in order to actually impact those and drive towards those goals, really it's all about decisions and what decisions you're making within the organization. So those could be large capital investment decisions, and such as investing in new assets and new equipment, or it could be simple day-to-day operational decisions like where are we going to send our trucks today. But the way that analytics actually impacts the organization is through those decisions, right? So any analytics initiative should be trying to drive better decisions. And the way we do that is really the way we use analytics to make better decisions is we learn from past events and past data to make predictions about future events. And then we make decisions around those predictions. And that could be something that's happening all through analytics and through computers and machine learning models, or it could be happening all within the heads of your subject matter experts in the field, or somewhere in between, right? But ultimately, that's the kind of the pattern that happens, and the goal of our analytics is really to drive more data-driven decisions around that. So a very important part of generating those predictions is getting the right context around any data that you're basing those on.
And then that context can be very simple, right? We spoke about you need to kind of know where you're coming from to know where you're going. So historical context, just the concept of time. What did I produce the last hour? What did I produce the last shift? What is my rolling average for my past 3 shifts? So just creating context of time already adds a lot of statistical analysis that can be derived from that. And obviously, the further you want to go with your analytics, yes, definitely. The more events you can then apply to that, And the more metadata that you can associate to those events will give you just more context and more context. And the more context and conditions you can associate with that periods in time, the richer and the more type of questions will you be able to answer from that. But what
absolutely.
in the industry is just that underlying fruit or that massive value that you can already tap by just adding time as context to your historical data.
Yeah. Yep. And that, so yeah, as you said, time, one kind of grouping of context that we add. Another is events. So for instance, a very basic one there is, when was a piece of equipment last maintained? That's an event. And then conditions would be things like, what's the weather doing? What's the quality of crude that we're flowing through a pipeline or into a refinery unit or something like that. All of that is kind of those conditions. But then a very important piece of this is the calculations. So bringing together that context with your operational data coming off your SCADA system, you're calculating those key metrics. So as you said, just with time, you have rolling statistics and hourly, daily totals, things like that. But then it's also things like how many hours have we operated this equipment since its last maintenance? What volume of different types of crude have we flowed through it? All of those types of calculations are things that have a very concrete impact on things like maintenance and when you need to make decisions around that equipment, right? So those calculations, though, and the relationships and what is important in terms of that context is often held just within the heads of your field technicians, your operational teams, right? The data scientist working on your cloud platform generally doesn't know what's going to be important in terms of those relationships and those calculations.
And even if you had a well-documented source that would say, hey, when this tag says state 10 or 20 or 37, it means this, or this, the likelihood of that staying universal across all of the operation or across all of the equipment or across all the line, this is where the scalability issues really come into play. Now, Streamline, go ahead, Dan. Sorry.
I was going to say, and as well, things like you might understand that about that one tag, but do you understand that tag also relates to another to two different pieces of equipment? And right, like there's a lot of kind of tribal knowledge within the operations teams that needs to be captured.
That's right. And Streamline has got a good bit of experience working inside of these operations, right? Tell me a little bit about the tools that you keep in the toolbox for you and the team.
Sure. Yeah. So when we start looking at kind of how do we bridge that gap with those operations teams and the cloud platforms, this is really where Streamline and Flow come together. So Streamline, we've been a systems integrator for operational systems and SCADA systems for 13 years. And early in that journey, we partnered up with Inductive Automation and became an integrator of Ignition. And we did that because Ignition really we saw as this modern technology that was easy to implement, but provided a whole toolbox of things that you can use it for in terms of building HMIs, building those real-time applications with that real-time data. We've now partnered with Flow for very similar reasons. We see where Ignition shines on the real-time side with HMI's real-time integration. Flow really shines in terms of contextualizing that data, but it also provides that same kind of approach where it's this modern technology, easy to implement, and provides a whole toolbox of capability around that core implementation. So we see the two as very complementary, where they work very well together. Yeah.
And let's talk just a little bit about the strategy side of bringing data from the producers on the operational edge to the application layer, I often call it, or to the enterprise, to the other tools that need access to it. It's important that we just recognize that that process to go from raw data to actionable information is really the same process that we've known to follow for 30 years. We're not reinventing the wheel by any form here, but it's that process that has actually caused all of the problems in bringing contextual information into the cloud. And let me explain why. As you know, we always end up connecting to a data source, we meaning the industry, when they solve these types of problems. They ingest data. Then that data has to be normalized. Timestamps have to be aligned. Different formats of different databases that are underlying have to be standardized. The data has to be cleansed, filtered, anomalies eliminated. And then what we're talking about today, all of the context that's in the heads of the subject matter experts, the men and the women that are your engineering core, needs added to that data. Then you're ready to aggregate it, calculate it, come up with KPIs, identify event frames, validate the results of those calculations, and then distribute that information. The issue is, if we take a page out of the Industry 3.0 playbook, the way that we've been doing this, where has this process lived to go from raw data into information? It's been scattered across many of our different data consumers, meaning if I have a BI tool, I connect that BI tool to all of the relevant data sources. I bring all of that data into the BI tool. I go through these steps to go from raw data to information. I do the same thing in my data warehouse or my data lake. I do the same thing in my machine learning models. I do the same thing in my notification servers for my Slack or my Teams. I do the same thing for my dashboarding. I keep doing it over and over and over again. This is a simplified version of what actually these architectures look like. And it's very code intense. It's redundant, meaning not in a good way. It's redundant in the fact that I continue to orphan work that I could not reuse in other applications. It's expensive and it doesn't scale. Not to mention the fact that how would you govern the definition of a KPI if it exists across 7 different applications? So Flow's message it's really important. I want to make sure that I clearly communicate. Flow in no way is saying don't take the data into the cloud. Don't take the data into Power BI. That's not the message. We think you should. But we want to provide a single place where you're able to, without writing a bunch of code, put all of your subject matter expertise into contextualizing that information, having a single place you can govern templates of this process to go from raw data to information and make it scale really well. Now, before Lenny jumps into the demo to show you how this can be done in 3 different use cases today, Lenny, can you give the audience just a look under the covers of what's actually happening on the Flow platform in the background?
Sure. Obviously, we're talking about transforming data into information, right? So we need to collect data first. Now, Flow can connect data from various types of data sources. If we go from the bottom of the list there, our typical traditional transactional data that might be sitting in a SQL database. Think about in oil and gas, a batching database as an example. I want to know what is the sulfur content for a batch that's incoming. That will be a transactional database that we can query and get that information from. Real-time sources, invent of industrial Internet of Things, MQTT brokers, all little sensors that can now push data and provide more context. We can go and buffer those real-time sources as well and add that as context. Data that's already stored in industrial historians, time series data that sits in those industrial historians, we can get that data out. I think one that's often neglected in a case, especially if you just push data to the cloud, is what about data that a human needs to add, manual data? There's some data and context that a human needs to provide that can add tremendous value to adding more context to your analytics. So we have the capability for the human to interact and provide context as well. We then need to clean this a little bit, potentially. We need to clean the data, maybe filter out outliners, filter out bad quality that we might get from these sources. We might need to do some calculations based on these raw tags, and the Flow platform gives you the capability to do that as well. And the way that we do that is we will go and create what we call a normalized data set from the data coming from these different data sources. So at any point in time, or at timestamp, that you will have data from the SQL database, in this case, that batch ID number that you guys can see there, with data maybe coming from a real-time source, kilowatt hours, or data from your time series historians, in this case, the total production for the day. All of that is now normalized in one row. And if I've had that one row normalized with all of these data points, then I can really go and create context and calculations based off that. We really want to go and look at what is the SME's, what's in his brain, right? Like Dan explained, analytics is not just maybe something that you've built a machine learning model for. It's maybe done as tribal knowledge in that guy's head all of these years. So we really would like to collaborate with those SMEs and then derive a set of KPIs that they use in a daily way or to identify problems, and always relating back to the business case, like Dan mentioned, and really operationalize those KPIs. And the way that we do that is obviously we'll take the raw data that's now being crunched, we'll take the knowledge of the SME, and we will go and define a set of KPIs. We'll operational those KPIs. That means that they will execute as they need to, as data come in on a certain time interval, or if a certain event occurs. The point is that that data and that KPI is turned into information that's readily available for the operations team to make decisions based on that. We will present that in Flow dashboards. We can present it out as notifications to people, but it's really then a place where operational staff, even from lowest level operations all the way to exec, have access to this KPIs that's now being operationalized within the platform. We're not a black box. Not those KPIs that's been operationalized doesn't stay inside of Flow. That can now be shared outside. And I think this is the point where this rich contextualized piece of information can now be shared with the cloud providers. It can be shared with a data lakehouse provider or a data warehouse. It can be shared with BI tools. Even complement your existing UNS with this rich historical KPI information. And the way that we do that is we have technologies to push the data out. So we call them data syncs to these different applications, but we also have a REST API where people can query the Flow model and the information that sits within those models and KPIs.
And Jeff mentioned earlier that there's a strategy issue that's leading to those kind of the incomplete picture in the cloud, right? This, I think, really highlights a better strategy in that you're targeting your operations teams first and providing value to your operations teams first. In that way, they are actually motivated to provide the right KPIs, the right and the right calculations and context into this whole system, and that then the rest of your organization really inherits that knowledge, and it's a way that you keep that knowledge coming in by providing value back to the teams that are giving it.
And Lenny, if I'm not mistaken, part of your demo here at the end is you're going to use the data sync component to actually do this and push this data to a cloud solution live in front of us. Yeah.
Yeah.
Okay. Perfect. Well, talk to us just a little bit more about this continuum of analytics. Like, what is in the heads that we're looking to bring out, just to make sure we're really clear on the amount of context that your engineering core has that your enterprise data scientists and data teams don't have.
So it can be as simple as just descriptive analytics, just based on prehistoric events, prehistoric values that can be shipped, again, like we said, based on a time frame or time range, just what happened. And based off that, the more context based on conditions and events we can add, then we can move into the second layer of analytics, which is our diagnostic analytics, where we can then start to answer questions around, okay, we know what happened, but why did it happen? Was it a particular shift? Was it a particular batch that we got that's got some dodgy crude? And that's where you can start adding more and more questions. Is if you add more and more context, then you can answer those questions. And then if we know why it happened, we know what happened in the past, then we can extrapolate into the future using simple statistical analysis, maybe a little bit of regression analysis. We can then start to predict, well, if I know what my running rate was for the past shift, let's extrapolate that running rate into the future, and maybe I can get what's my expected barrel production at the end of the day. Or I've got this amount of sulfur in my crude, I'm mixing it into a tank. What is my hourly updated sulfur levels in that tank? And then we can do a little bit of predictive analysis on that. And if you've got all of that, well, then obviously what everybody's striving for in analytics is this whole notion of prescriptive, right? Okay, we know what's going to happen, either being good or bad. If it is bad, what is the top 5 things potentially that I need to do or should be done now to make sure that it doesn't get to that situation in the future? And what we're really seeing is that there's so much value still unlocked in just that first 2 parts, just the descriptive and the diagnostic section around analytics, even before we get to predictive and prescriptive type of models.
And so that, I think, brings us, Dan, to our first use case today, and then Lenny's demo.
Yeah. So for our first example, our first use case, we're going to be doing an upstream use case around well production. And we're really going to be providing that historical context and then performing some regression analysis. But I'll let Lenny take that away and kind of show us what can be done here.
Perfect. Thanks, Dan. All right. So what you guys are seeing is a flow dashboard. This is one of the places that we can end with a KPI, is having it available on our flow dashboarding capability. And really what I've got here is a total well production kind of dashboard, an overview of all my well productions. I've got my monthly progressive totals at the bottom here. So you can see this is extrapolated into the future, and I can see at the end of the week where I'm going to end up from a well production perspective. But something that's a little bit concerning for me here is if I look at my daily well productions or my daily production totals, if I pop this part out of the dashboard here, you'll notice that I've got this blue line going over the historical data. Now, this little blue line is just very simple regression analysis that I've applied to the historical data. It's negative, so it's in a downward spiral. So obviously my total well production is taking a little bit of a knock. We can see there what the equation is that the regression analysis spat out. So I would like to understand a little bit more. Why is my daily production in this kind of downward spiral? And in order for me to do that, if I can maybe predict what my wells are doing, individual wells, maybe I've got a clearer picture of what's actually happening with my total well production. Now, in order to do that, I'm going to go into Flow. This is the configuration tool that I will use to build out, first of all, a model. So you'll notice on my left-hand side here, I've got a model, and I've modeled, in this case, 5 wells that I've got in my operation. And each well will give me the capability to look at its production. So what is its current flow rates, what its casing pressures. Based on the flow rate, I can then say, okay, what is my month-to-date flow rates, my daily flow rates. And based on that, obviously, I can build statistics around my total production. So that's what you saw on the dashboard, was my total production for all of my different wells. And I did use a little bit of 7-day moving average statistics, rolling statistics, to get a projected total for my total well production. But obviously, I want to do that now for each and every one of my wells here. I'm not going to do it individually to each of those wells from a time perspective or an engineering perspective. There's better ways of doing that. The way that I'm going to do that is I'm going to utilize Flow's templating capability. So if I right-click on this in my model, you can see that I have derived this from a well template. So I've got this well template that hosts all the inputs that I'm getting from my control system, in this case, all from a time series historian, and then all my KPIs that I'm going to derive from this. So I'm going to expand on this model. I'm going to expand on this template. One thing that I'm going to include here is obviously my prediction. I want to see if I can use very simple regression analysis to predict what my well is going to end up from a barrel production perspective. So let's add a new metric. So I'm going to add a new metric to my template here. A metric is what do you want to measure? In this case, I want to know what is my well prediction. So I'm going to create a prediction metric within Flow, and I'm going to utilize 1 point from the time series historian, which is going to be my flow rate. Okay, this is the raw tag from that historian. Remember the steps that Flow does. We first connect to that data source. We potentially do some calculations on that before we create the aggregate. So this is this raw calculation point. Very important that Flow will never ever duplicate that raw data that sits at source. We will just query it, clean it, and then store the result of the aggregate or KPI in our database. Right, so let's do this. Let's create a minutely calculation based on that flow rate. So this is going to be my actual flow rate, and I'm going to move it into my prediction metric here. Now, I might want to go and clean this or transform this data, which I'm definitely going to do because flow rate is in gallons per hour, but I want to transform it now to what is my barrel production going to be. So this is this first part of cleansing that we're going to do is I'm going to convert gallons per hour to barrels. And the way that we're going to do that is with the scaling factor here. Now, I've already worked this out, so I'm just going to use my little cheat sheet here to copy this out. But a gallon, or there's 42 gallons in a barrel per hour. I need to convert to minutes. So I've got the scaling factor that's pretty much going to convert this to barrels per minute in essence. Okay, so I'm going to use that scaling factor to do that for me. So now I've got a total minutely barrel production. I would now like to go and potentially know what is that for the hour. So I can literally just drag it onto my hourly icon, and that will give me an hourly production KPI. I can also go and create progressive total. So I can say, you know what is my hour to date or my shift to date? So if I drag this onto the minutely icon again, it's going to create an hour to date total. Drag it onto there again, shift to date. Drag it again, I get a day to date. So I get progressive day-to-day totals as we go along. But let's look at some statistics. Now, Flow has tools in its toolbox here that has some built-in functions that's available for you. And some of these functions are normal aggregate functions. So if I want to look at the mean or the standard deviation, I want to create some histogram buckets of my data, those are available. But what I'm going to use for today is my regression analysis. So I do have some regression functions built in with the product where I can go and look at just a very simple line fit regression with projection into the future. I could have getting my slope of that line if I wanted to. Where does that line actually intercept at the bottom? And then I've also got two polynomial functions here as well. I'm just going to use the standard line fit predicted function there as well. You can create your own user-defined functions as well. In this case, I've created one that's going to help me with my projections. So you can utilize these functions and then create a complete custom based on what your requirement is at the end of the day. So let's go back to my template. In my template, what I'm going to do is I'm going to say, okay, let's look at a calculation. So I'm going to drag this onto my calculation here. And this is now where the SME collaboration comes into play. How many data points, historical data points, do I actually now want to use within my regression analysis? I don't know, as the guy implementing, I don't know, I've got no idea about well production and how many data points you need to use. So I'm going to guess, I don't know, let's say I want to use 2 days worth of data. So I'm going to say 2 days regression. And I want to predict what's the next point with that. Okay, let's open up this calculation. Let's change it that I actually look at a range of values that I'm going to use. So I'm going to change this to not the current 5-minute period, but again, a range. So using the statistical range functionality. And I know that 2 days worth of 5-minute periods, that's 288 periods that I'm going to feed into my regression model. I'm going to go to my toolbox here, and I'm going to drag this little function in that I've created. And all I need to do is to say, okay, I need to supply it with all of these range values. So I'm going to supply it with my range values there. And how many periods in the future do you want to project? Well, just the next bucket. So we'll just project once into the future. Validate the calc, and there it's running. It's ready for me to use. All right, now I've done this before. So if I look at my well number 1 here, if I look at my wells, I've got my production here, and there I've got my projection done. So I've done this. I've created this 2-day regression analysis, and I also have my flow rate that's now in barrels. Let's look at the data quickly, though. Let's pop this out. Let's look for the past day. So this is my aggregated period of 5-minutely periods of barrel production. So that's how many barrels I produce every 5 minutes. Let's look at the 2-day regression analysis that I've applied to it. So let's drag that in. Okay, so what I see here is my regression is not really plotting nicely against the data. So maybe that 2-day range was too much. And this is, again, we need to have this collaboration with our SMEs to tell me, listen, yeah, 2 days is going to smooth out that projection. You're not going to really get a nice answer. So again, I can do the exact same. I can go back in my template. I can say, you know what, let's create another calculation. And this time, not 2 days worth, but let's just do 2 hours worth of regression on the data. Open this up, same story. I'm going to look at a range. And in this case, I'm just going to do a range of 24 periods. And again, utilize my little function from my toolbox that I've used and replace the parameters for that. Okay, again, just 1 period into the future. That's good enough. I've done that again, just for the demo's sake and just for time. I've done it. So I've got my 2-hour regression here already. Let's drag that into the fold here. And you'll notice that tracks way better of what actually is going to happen. So it's quicker to react to the fast changing barrel production that we see. I can obviously use this regression to also create a projected total for me for what is my day-to-day projection looking like, and where potentially can I then end up from a daily projection. So let's add the projected into the fray as well. And let's just move it 2 hours into the future. And if I do that, you'll see, there we go. So there's my projected production for barrels 2 hours into the future. And if I look at my day-to-day total, it will also project that into the future. And at the end of the day, I can see potentially where I'm going to end up from a barrel production perspective by just using this regression analysis on rolling time that we've got there. When I'm happy with my template, I can go and release it, make sure that I want to go and now instantiate it into production. So I can go and release it, and then I can go and update my templates here. And then all my wells will utilize the exact same calculation, the exact same rules, so that I can really go and compare wells with wells and be confident that every well will be calculated with the exact same way or flow. Thanks, Jeff.
Very cool.
Yeah, thank you, Lenny. Just 2 quick questions, Lenny, on this. Could you weigh your projections based on using both the 2-hour and the 2-day?
Yes. So you can build in factors to say, use X amount of my daily or my 2-day regression, and more weight the 2-hour regression to give you kind of a factor that you can then multiply with. So definitely you can utilize that as well to get to a better answer as well.
And if there's a certain condition in play, then use a different weight versus another, and so on. I'm sure. And then on your template definitions, maybe you have maybe not all wells are the same. I assume you would just create different templates for different types of wells, or would they share the same base definition? What do you see typically done?
They will share the same base. You will derive from that base, and then whatever small little tweak or change you need to do based on different types of wells or different pieces of equipment, you will do that in the derived template, but they all start off from the same base. Yes.
Okay. Thank you. All right. Well, Dan, what about our next use case?
Yeah, so our next one we've picked is a midstream use case, and this is looking at tank volumes and basically just doing a real-time estimate of the current levels in the tanks, and then importantly being able to manually capture a measurement to re-baseline that value.
I think the problem that we're solving here is that, Dan, correct me if I'm wrong, but normally they will just do a weekly kind of, dip to see what the actual stock level in those tanks are. But based on inflow and outflow in and out of the tank, we can very easily create a more realistic, up-to-date, real-time inventory level. Then obviously when it does come to do that manual take, we just rebase and then work from that. Again, if we go into what we've done there, is very simple. Simple, like Dan said. We've created an hourly stock at hand KPI. So what I'm doing there is I say, well, I know what's coming into the tank, the total flow coming in. I know what's going out of the tank. I can go and look one period before to see what was my previous hour's stock at hand. And based on in and versus out, a little bit of mass or stock balance there, I can then say, okay, I predict whatever the stock is currently. But very importantly, as you can see in that graph, that we're definitely pumping out more than what we're getting in because my stock level is decreasing every hour. So it's a downward spiral that we can see from there. So we're using multiple points into this calculation. And that data could have come from any data source, doesn't matter, but because we do that normalization, we do that. Jeff, if you can just progress. All right, so as I explained, we use that same normalization idea to normalize the data that we can do these type of calculations with. And very importantly, in this case, we need to be able to get manual input. Now, Flow, with its dashboarding capability, has the capability to provide a manual input form. So what you notice there is at 6 o'clock in the morning, these guys went and did a manual inventory check. So they re-baseline. They told us that what is the current real-time stock. We will use that into our calculation and we will re-baseline to say, okay, currently the stock at hand is X. And then again, as we go through the hours based on the volumes getting pumped in and out, how does that then change for every hour? So instead of having a real-time inventory every week, we now have a real every hour updated stock level of what's happening in the tank.
And the official record is from the dip, from the hand dip measurement.
Correct.
But the benefit, of course, is every hour or every day or in between those official measurements, you have a calculated estimate. But at any point, the dip overrides that as the official record and could be manually entered into Flow, or if maybe there's another database where that's already being entered.
Correct.
Flow would just pull that. And I think then the final use case.
Yes. Yeah. So this one builds on the last one. And makes it more, I guess, relevant for a downstream operation, maybe a refinery that really cares about the sulfur levels coming in on the crude coming into their refinery. So yeah, we're basically adding a sulfur calculation, content calculation in. Maybe Lenny can take us through that.
Perfect. So in this use case, we're now introducing this concept of not just time based on hours, days, or those periods, but also now a little bit of batch information. So in my data source here, I've got data sources. This is data coming into Flow. So obviously I had my historical data or my time series data, but I also had this crude receiving database, where this will now tell me a little bit more information around what is the current crude or the batches of crude that I receive, and when did that batch start, what is the current sulfur content of that crude, and what is the type of crude, is it sweet crude or sour crude that I'm actually receiving. I've modeled that within Flow. Again, the model on the left-hand side here, I've got this event. Now we will use events within Flow to track these different batches that occurred. So I've got my batch receiving event, and based on that, I've got this notion of, I know that the content is sweet or sour. And based on that, obviously, the sulfur content will change. So it will be higher for a sour crude that's coming in. Now, in order for me to utilize this now in calculations to get a more real-time sulfur content, what we are pumping into the refinery, I can go and transform this transactional record within Flow, and I can actually make it back into a tag. So I can take transactional records and make it more record that it looks like time series data. So I've got this capability to take event data within Flow, do a tag transformation on that, and I can actually strip out just the sulfur content side. So if I look at a few days in the past when I received my new batch, I can see the current sulfur content is 3.8. If I look a little bit further back, I can see how that sulfur content changes as my new batch include and is getting allocated. And with that, I can now get a hourly sulfur content that's coming into my tank. And again, I can go and create a calculation that's going to spit out what my current sulfur in the tank is. And I do have that capability, again, to re-baseline. So if I go into the front end here, I've re-baselined my sulfur. Maybe there was a manual check, but you'll notice I'm slowly but surely increasing the sulfur content because the incoming crude is sitting at 3.8. So every hour, as the volume of crude is coming in and mixing within the tank, it will slowly but surely increase that sulfur content. And I've got this real-time sulfur content calculation in my tank as well.
That's great, Lenny. Thank you for walking us through those different use cases. And I want to obviously talk about what you've shown is powerful, right? You've got the knowledge from the engineering core, from your frontline employees coming into the data. But I want to call out the fact that if it just stayed inside of Flow, it would be helpful to those attached to Flow, right? Doing their work within Flow, but it wouldn't help the rest of the enterprise. And that's why, to come back to your points earlier when you did the behind the scenes of what's happening in Flow, the fact that Flow then shares this information wherever you need it to go is crucial. And so that means if you need Flow to push information back into your Ignition ecosystem, check, or back to your historian, check, or into another database like a SQL database or another application like a BI tool. But in today's demo, you're going to show us how to bring that into the cloud. And Snowflake, is that what you're going to demonstrate?
That's correct.
Okay.
Cool. So I've created a Snowflake database, very simple. It's called Flow. Within that Flow database within Snowflake, I've got my data schema here. And within that schema, I've created a little integration table. Very simple little table. It literally gives me the entry ID of how many entries I'm pushing into it, the start and the end period of the data that I'm pushing. And then I've created a little object in the table. So that will be a JSON blob that I'm going to send across that will have all my contextualized information associated with that. If I go and look at the table now, this is just a select statement from that data. there's no results, so there's nothing getting pushed to this right now. So how do I now tell Flow to take this regression points that I've created and push it out to Snowflake? We spoke about it as the data sinks that we can go and add to Flow. And just like I have this notion of different sources of data coming into Flow, I can have different types of sinks that goes out. We call them consumers. In this case, I've created a Snowflake database consumer, but I could have pushed it to a Microsoft event, or I could have pushed it to an AWS Kinesis stream, or I could have just pushed it into another SQL database. So we have, and again, also to potentially just an MQTT broker. So we've got all these different places that we can then push the data out to from Flow's side. So I've got this Snowflake database here. Again, it will just show you what is the data schemas and tables that's available within Snowflake, and there's the definition, the schema definition. The nice thing about this is I don't need to have a fixed schema. This schema that's defined within Snowflake, you can go and configure, and we will just push the data into your designated schema. Now, again, I'm not going to do it to each and every one of my wells here. I'll do it on the template. So I will go to my production template here, my prediction that I've just created, and then this 2-hourly regression template of mine. I have the capability to go and configure integration. So I will go to this Snowflake integration. I will drag it onto this, and then I will have the capability to go and write queries. What will be my insert queries, my out to mimic my actual schema that I've created. Now, I've done this just before. So again, in my prediction here on my hourly to hourly regression that I'm doing, I've added in the integration, and I'm going to deploy this out to start pushing data into that Snowflake database. Important with this is that I do have the capability to backfill. So I can go and push historical data that's already sitting within Flow, and I can go and push it out. So I can go and give it a deploy command to start pushing it out, and it will start pushing the data every hour as there's new data coming in, or potentially old data that changed. We will then re-push with this mechanism.
And you could batch that into different timing intervals as well if you found it to be more economic to move data in daily batches or weekly batches, correct?
Correct. Based on the time frame of the KPI, we can then push daily values or hourly values. In this case, I'm doing minutely values. So let's execute this, and there we go. So we've got some data getting pushed here. Entry of the data point, the period start for which 5 minutes this period is. And then here's that little measure object that now has the description, the hierarchical name of where it sits in the Flow model, the interval, it's minutely, the name that it's this 2-hourly regression that I'm doing, what is the quality of the point, the unit of measure, and the actual value itself. So all of this metadata is then associated with that point. If I had an event or some more context added, obviously this row of context added to this point will just grow. But yeah, that's how we share the data out and then push it into the technologies that wants to consume this data out of Flow as well.
And so additional context, just can you give some examples, and maybe not just in an oil and gas example, but like what other type of context might you be able to, or might you kind of be added?
In this case, I could have added the context of the batch that's coming in, right? So the batch number of crude as an example. Downtime. If I have an event that's tracking downtime of a piece of equipment, I could have added the context of the reasons, the discipline that downtime is associated with. Was it a micro or a macro stop event causing that downtime? So all of that additional method. Who was on shift? What shift was it? Was it shift A or B or C? So all of that type of context to answer more of those questions, we can then add and slice onto our data as well, and then obviously provide that context to the other systems as they need it.
Thanks, Lenny. Dan, will you kind of, what's the next steps if somebody's interested? How do they reach out to Streamline?
Yeah, I mean, we hope we've provided some good relevant information for our customers and for the people attending the webinar today. So if this has piqued your interest, we strongly encourage you to reach out and schedule a complimentary 1-hour consultation with us. We can kind of go through what your data needs are and how this might fit. You can do that either, I guess Jeff has dropped my email in the comments, so you can send me an email directly, or you can there's a link as well for a contact info to request more information.